The maximum subarray problem is the task of finding a contiguous subarray with the largest sum, within a given one-dimensional array of numbers. Professor Ulf Grenander was a Swedish statistician and professor of applied mathematics at Brown University. His early research was in probability theory, stochastic processes, time series analysis, and statistical theory. In 1977, Professor Grenander encountered a problem in pattern recognition, where he needed to find the maximum sum over all rectangular regions of a given array of real numbers. This rectangular region of the maximum sum, or maximum subarray, was to be used as the maximum likelihood estimator of a certain kind of pattern, in a digitized picture. Maximum subarray problems arise in many fields, including genetic sequence analysis, computer vision, and data mining.
In today's episode of
Wow! How'd you code that?
we are solving the maximum subarray HackerRank challenge. The problem statement reads: we define subsequence as any subset of an array. We define a subarray as a contiguous subsequence in an array. Given an array, find the maximum possible sum among 1. All non-empty subarrays. 2. All non-empty subsequences. Print the two values as space-separated integers on one line. Note that empty subarrays or subsequences should not be considered.
For example, given an array consisting of -1, 2, 3, -4, 5 and 10, the maximum subarray sum is comprised of elements at indices 1 through 5, and the sum is 2 plus 3 plus -4 plus 5 plus 10, for a total of 16. The maximum subsequence sum is comprised of the elements at indices 1, 2, 4, and 5, and the sum is 2 plus 3 plus 5 plus 10, for a total of 20.
After hearing of the maximum subarray problem at a Carnegie Mellon University seminar, Professor Joseph Kadane quickly designed a linear time algorithm to solve it. Kadane's algorithm scans the given array from left to right. In each step, it computes the subarray with the largest sum. It also computes the subarray with the largest sum anywhere between the first and the current index. As of today, Kadane's algorithm remains the fastest method for solving the maximum subarray problem.
Using Kadane's algorithm, the solution to this problem is rather elegant. First, we initialize three primitive integers: max SA, the maximum subarray value; max SS, the maximum subsequence value; and max, the maximum subarray value at the current index, to the value at the first index in the array. We then define a loop that walks through each element in the incoming array. Next, we determine the maximum subarray value, up to the current index, and store the value in the primitive integer, max. Next, we determine the maximum subarray value, which is the maximum of the primitive integer, max, and the current maximum subarray value, and store the value in the primitive integer max SA. Next, we determine the maximum subsequence value, which is the maximum of the value at the current index in the array and the current maximum subsequence, and the maximum subsequence plus the value at the current index in the array. We store the result in the max SS primitive integer. When all elements have been evaluated, the values of the maximum subarray and the maximum subsequence are returned to the caller as a primitive integer array.
Do you have a question about this solution? Post it in the comments below. If you want to see more unique videos like this, subscribe to this channel and click on the notification bell to be notified whenever we post new content.
Thank you for watching.
And we'll see you in the next episode of
Wow! How'd you code that?